What do you think of when you hear the word slope? You might think of how something slants, either uphill or downhill. Do you want to know what I think of when I hear the word slope? When I think of the word slope, I think of ski slopes and the beautiful mountains in the California Sierras. While this may not seem like a good place to talk about math, it's actually an incredible location. We're here to talk about mathematical slope, or the steepness of a line. And what better place to talk about steepness than here in the mountains? Come on, I'll show you. Many of the roads in the Sierras are cut right out of the mountain. Some are so steep that they can be dangerous for truck drivers who carry heavy loads or who have trouble with their brakes, especially when the roads are icy. For safety purposes, signs are posted on the roads to inform drivers when there's a steep hill ahead. A sign like this one tells drivers exactly how steep the road is so they can proceed safely. But what does this sign really mean? What's a 5% grade anyway? If a hill has a grade of 5%, it means that for every 100 feet you travel horizontally, you gain or lose 5 feet vertically, depending on which way you're driving. So, driving down this hill, for every 100 feet of horizontal change, there's a vertical change of 5 feet. This pattern repeats itself as long as the road maintains the same grade. Sometimes the vertical change is referred to as the rise, and the horizontal change is referred to as the run. The ratio of rise to run is called slope. The slope of a line describes its steepness or rate of change. Let's take a closer look at rise and run. One way to find the slope of a line is to use the rise and run to make a slope triangle. To do this, there are a few things you need to know about measuring the rise and run. When you move to the right in the positive direction on a graph, your horizontal change, or run, is positive. And when you move to the left in the negative direction on a graph, your horizontal change, or run, is negative. Likewise, when you move up in the positive direction on a graph, your vertical change, or rise, is positive. And when you move down in the negative direction on a graph, your vertical change, or rise, is negative. Let me show you how this works. Say you want to measure the slope of this line. First, pick 2 points on the line where you can clearly read the coordinates from the graph. These should be places where your line intersects the corners of the squares on the graph paper. Next, using the graph paper lines as a guide, draw a right triangle, marking your path from one point to the other. It doesn't matter which point you start with and which point you end with. For example, I can start at this point and rise 2 spaces up in the positive direction, and then run 3 spaces over in the positive direction to reach the other point. Or I can start at this point and rise 2 spaces down in the negative direction, and then run 3 spaces over in the negative direction to reach the other point. The triangles that are formed by marking the rise and run from one point to the next are called slope triangles because they help you find the slope of the line. As we've seen, slope is equal to rise over run. To find the slope of this line, then, we just put the rise and run into the formula and solve for the slope. We can use the information from any triangle along the line, so long as the rise and run come from the same triangle. So, using this triangle, where the rise is -2 and the run is -3, the rise over run is -2 over -3, which is just 2/3. This tells us that this line has a slope of 2/3. If we use the other triangle, where the rise is 2 and the run is 3, the ratio of rise to run remains 2/3, again showing us that this line has a slope of 2/3. Therefore, the slope, 2/3, describes the steepness of this line. It means that if we start at any point on the line and rise up 2 units and run over 3 units, we'll end up at another point on the same line. We can keep doing this over and over. The slope is constant along the entire line. Therefore, no matter what 2 points you choose to draw your triangle, you will find the same value for the slope. For example, what if we pick these 2 points to make our slope triangle? This point and this point. To go directly from one point to another, we can rise up 6 units and run over 9 units. Using these values to compute the slope, the rise over run is 6 over 9, which reduces to 2/3. So you see, regardless of which 2 points you choose to make your triangle and which direction you choose to draw your triangle, there's only one value possible for the slope of a particular line. And drawing a slope triangle to help find the ratio of rise to run is one way to determine that value.